Hello everyone, welcome to my chemistry channel B.L.DASH short and sweet in chemistry. Now I am going to explain in this my video, that is part 11, that is reactions of alkene, that is mainly oxidation. Oxidation of alkene. In my previous video I have already explained different type of reactions, just like addition, addition reaction, different type addition reaction here, halogen, hydrogen, halogen halide, and etc. Now here we will see the oxidation. What is meant by oxidation? Addition of oxygen. But addition of oxygen, that means it carries by different media, different medium. So here it is aqueous solution of KMnO4. There is no acid, no alkali, simply aqueous solution, and temperature, that is cold dilute. Cold dilute means ordinary temperature. Now here if you take alkane and cold dilute aqueous solution of KMnO4, it gives vicinal glycol. Vicinal glycol, what is that? That means OH2 OH group are attached to adjacent carbon. Now pink color of KMnO4, you know, potassium permanganate is pink color, the solution is pink color, and here discharge. It indicates that this is very important test for unsaturation. What is mean unsaturation? That means here the alkane, which is an unsaturated compound hydrocarbon, because here it contains double bond. Double and triple bond compound hydrocarbons are known as unsaturated compounds, whereas single bond alkane is known as a saturated hydrocarbon. Now here the pink color of KMnO4, if discharged, is sure that it is an unsaturated hydrocarbon. Now example ethane, if you take water and dilute KMnO4, we supply oxygen, nascent oxygen, it forms CH2OH, CH2OH. That means the OH group attached to two adjacent carbon, that is why it is called vicinal glycol, and here ethane 1,2 diol. Di mean 2, all mean alcohol, OH group. So ethane 1,2 diol. Now if you take, this is known as symmetrical alkene, if you take unsymmetrical alkene, but here there is no problem. Here again you will see the OH group will where it will attach. OH group where it will attach, here one OH group, here one OH group. That means double bond is there, double bond left side one OH group will attach, and right side also one OH group will attach. CH3, CHOH and CH2OH. What is the name? This is the main hydrocarbon. Parent hydrocarbon is alkane, that is propane, and in propane 1 and 2 position the alcohol group, OH group is attached, and that is why it is known as 1,2 diol. Again see, this is parent hydrocarbon, that is propane, in 1 position OH group, 2 position OH group, that is why name is propane 1,2 diol. Now these are the reaction, that means when it is the solution of KMnO4 is cold or normal temperature. But when you see hot dilute KMnO4, then what happens? You know ethane, there are 2 carbon, CH2 double bond CH2, 2 carbon. When you treat hot dilute KMnO4, then what happens? It gives one acid. Now see here 2 carbon, and it is one acid, 1 carbon acid, that is methanoic acid. That means it gives 2 times methanoic acid. It gives 2 times methanoic acid, 2SCOOH. What is SCOOH? Methanoic acid. And what is the common name? Formic acid. Common name is formic acid. LPC name is methanoic acid. If you see it is 1 carbon and it contains COOH group, surely you can say that it is methanoic acid. Again see alkane, the condition is cold dilute KMnO4, it gives vicinal glycol, and example ethene gives ethane 1,2 diol, propane gives propane 1,2 diol. And here if you treat hot KMnO4, and then it gives methanoic acid. Since there are 2 carbon, that is where 2 methanoic acid will get. one thing I want to say, one is terminal alkene, other one is non-terminal alkene. That means one is terminal alkene. Alkene means double bond. It contains double bond. Termin, that means at the end side the double bond is present. That is called terminal alkene. You see here ethane, it is one side end towards end, so terminal alkene. This is also one side, there is a double bond, terminal alkene. So these are known as terminal alkene. Then we will see what is meant by on non-terminal alkene and what happens when you treat hot dilute KMnO4. Terminal alkene. What is terminal alkene? That means this that means double bond should be in one side. One side, that is why it is called terminal alkene. One example I told already, ethene. Ethene is the simplest form of alkene, which is terminal alkene. Now other example of terminal alkane, that is propene. CH3CH double bond CH2, you know the double bond that is on the right side at the end side, that is why it is called terminal alkane. Then what is non-terminal alkane? That means the double bond should not be present at the side. It may present in the middle or far away from the side. That is why this example of non-terminal alkane, say butene. What is mean butene? Here CH3CH double bond. See, in the middle the double bond is there, but not at the end of the side. That is why it is called non-terminal alkane. This is known as butene because after 2 carbon there is a double bond. So it is butene. Next come to I want to say how it react with terminal alkane react with hot dilute KMnO4 and how the oxidation takes place by the help of hot dilute KMnO4. You should remember terminal alkane when react with hot dilute KMnO4, oxidation takes place and immediately corresponding to that carbon acid is formed. And now here, since double bond is there, surely it will break here, and it 2 times it break, then it gives 2 CH3 COOH. That means here it will give ethanoic acid and the formula CH3 COOH. Now if it is ethene, now see, if it is propane, 3 carbon 1 less carbon, acid is formed. If it is ethane, 1 less carbon, acid is formed. 2 carbon ethene, so it forms methanoic acid. Methanoic acid contains 1 carbon, so it is methanoic acid SCOOH. Then come to non-terminal alkane where double bond is not at the side, at the end of the compound, of the structure, and maybe in the middle. So example butene, here 1 2 3 4. After 2 there is a double bond butene plus the oxidation carries by the help of hot dilute KMnO4, it forms ethanoic acid. Now here you can observe how many 1 2 3 4. 1 2 3 4, that means the bond breaks here. 2 carbon gives 1 acid, that is ethanoic acid, and here it gives 2 times ethanoic acid. Next is 2 methyl butene. Why? How you can name it 2 methyl butene? See here, 1 2, it is 1, it is 2, it is 3, it is 4. After 2 there is a double bond, and in 2 position there is a methyl group, that is where 2 methyl, and the long chain contains 4 carbon butene. But which position is a double bond is there? After 2 carbon there is a double bond, that is why after 2 you will write ENE. That means 2 methyl butene, and oxidation takes place with the help of hot hot dilute KMnO4, it gives here remember terminal alkene gives only acids but less than one carbon, but non-terminal alkane it gives that means it gives ketone and acid. Ketone, how many carbon? 1, 2, 3. Because since it is non-terminal, and also you can find here this is the part where here it will break. Here it will break, and this is the part. And from this part, it indicates that they should form propanone, ketone. That common name is acetone. IP's name is propanone. So since it contains 3 carbon and keto group, that is propanone. And what is the remaining 2 carbon remaining? It changes to acid. CH3COOH. This part changes to acid, this part changes to acid, and this part changes to ketone. That means 3 carbon propanone, 2 carbon that is ethanoic acid. Again see 2 types terminal carbon, carbon here alkene, and one is terminal alkene, other one is non-terminal. Terminal towards the end of the formula there should be double bond. Non-terminal alkene may be double bond present, maybe in the middle, and terminal that is simply gives acid and especially less than 1 carbon acid, and non-terminal here it gives generally ketone and acid, mixture of ketones and acid according to the breakage of the double bond. Where double bond will break, it is very important. Where double bond will break, you will observe and you see what is the type of acid form. This type of reaction, non-terminal alkene oxidation reaction, is very important for different type of entrance examination. We can take other example of non-terminal alkene. This is very important. 2,3-dimethyl but 2-in. See 1, 2, 3. 2,3-dimethyl. After 2 double bond, but 2-in. This is also non-terminal alkene. And here what happened? This part is formed as ketone, and this part is formed as ketone. So, and how many carbon? 3 carbon. So it is propanone. Propanone plus propanone, and this is very important. Hot dilute KMnO4, it gives 2 propanone. Now acidic KMnO4 and acidic K2Cr2O7. KMnO4 and K2Cr2O7, they are very good oxidizing agent. In presence of acid, mineral acid, it changes to what? According to the condition of alkene, it forms ketone or acids. You can take acidic KMnO4 or you can take acidic K2Cr2O7, but here it forms ketone or acid. Then how can you know it forms ketone or acid? Depends on the nature of alkene. What type of alkene? Whether symmetrical alkene, unsymmetrical, whether terminal, non-terminal alkene will observe, and also condition, temperature, pressure, all the condition you will check. According to that the compound is formed. Now here 2-methyl propene, 2-methyl propene, house itself propene, and 2 position methyl, and here what happened? See, and it forms as carbon dioxide, and it forms as ketone, and 3 carbon, that is why propanone. 3 carbon propanone, CH2 1 carbon carbon dioxide. So there is very important, 1 carbon, it never forms any type of alkene or alkane, ketone or acid. That means it only that possible is carbon dioxide because it oxidizes, that is why. Now here but2-in, now here but2-in, it is symmetrical alkene and non-terminal alkene, and you take that means KMnO4 acidic condition, and here oxidation takes place. Then what happened? Here similar carbon and hydrogen present right side and left side. So here it forms C, and this form as 1 acid, and this form as one acid. Then what is that one? CH3COOH, CH3COOH. Again see, this is non-terminal alkene. It separates between double bond as ketone, propanone. And here alkene, that condition is acidic MnO4 acidic K2Cr2O7. It gives ketone or acid according to the nature of alkene. How can you get acid? How can you get ketone? When you see the alkene, it is already clear. You can understand what type of ketone, what type of acid it will form. Now, see, this is 2-methylpropene. Here you can see there is a chance, here oxygen will be added, then there is a chance to form propanone, and the CH2 will oxidize to carbon dioxide and water. And here butene, that means this side 2 carbon 4 hydrogen, this side also 2 carbon 4 hydrogen, because it is symmetrical alkane, and it gives this part as acid and this part as acid. That is why it is already told, that means it depends on the nature of alkene and experimental condition. So here it gives one acid, acidic acid, one is acetic acid. This is called acetic acid, or in IP's name it is called ethanoic acid. I hope this oxidation of alkene is clear to you, and hope you will subscribe my channel B.L.DASH Short and Sweet in Chemistry, and please like and share my channel, and thanks for watching my video. In coming video I will explain addition of ozone, ozonolysis of alkene. What is that one? Ozonolysis of alkene, and next polymerization. So ozonolysis and polymerization, two things I will explain in coming video, and thanks again for watching my video.